Okay, so the recording is starting in a few. You can see the GIF rotating. Awesome. So we are live online and we're recording this session. Today's speaker is going to be Collins. Collins, we are happy to have you here. We prepared some introduction for you. Chantel has access to it, but we can't find her, technical difficulties. So Collins, I'll just give you this opportunity. Introduce yourself, let the audience know you, and just talk to us. To the general audience, kindly note that this call will be recorded. Your image or your is available online. So we hope you're okay with that. And to Collins, this is also going to be uploaded to YouTube and everyone. So Collins, please just kick it off.
Right. So maybe a quick intro. My name is Mush, Collins Mucheru. I work at a company called Color. We're about, I'd say, 8 months old or so. The presentation is on Elixir Phoenix, Gitlab CI/CD, specifically Cloud Run. I know the topic was a bit wide, but I decided to focus specifically on Cloud Run for reasons I'll explain. So who am I? I'm basically just going to read this out. So I'm a full stack software engineer dabbling in DevOps, and I'm in love with Elixir, Vue.js, and GitLab. I started my Beam journey with Alan. So I'm currently privileged to work I'm currently privileged to lead an awesome team of software engineers at color.com, where when I'm not writing code, I'm probably listening to music, taking long walks in the woods, or obsessing about 2JZs and LS engines, among many other interests. So I think why Elixir Phoenix, I don't know if we need to answer that question, considering it's a Beam Kenya community, but the buzzwords usually are scalability, concurrency, mainly, and for me also the syntax. And then why GitLab? I'd say it's easy. It's also applicable and cheap, especially as startups go. So you guys know, maybe a year ago, previously you'd have to pay for GitHub to get private repositories, but for a while GitLab was free. And they also offered CI/CD services. So I saw it personally as like a combination of GitHub and CI/CD tools like Travis. So why GCP Cloud Run? For that, it's also another question of cost. So we pick specifically Cloud Run because, for one, you're charged based off of the amount of requests that come through. So whenever there's no request coming through, you're not being charged. So I find that easier. And then also, as far as Docker goes, you have to create Docker images to run on Cloud Run. So I view Docker as something, or rather, it is something that can be run on so many platforms. So you can create a VM, install Docker, and basically run your stuff there. You can deploy it on Kubernetes, and of course, you can deploy it on Cloud Run. So using something that follows an industry standard means that you're not bound to a specific provider. So that's another reason for Cloud Run besides the cost. And then I think one question that a lot of people usually ask is, do I have to add a credit card? So when you join GCP, when you have a fresh account that has never used Google Cloud, basically you get $300 worth of free credit for a year. So you're free to experiment with as much as you want. But then I would say, make sure to delete resources when you're done with them, or you'll exhaust your $300 without knowing how quickly they went. So there's other ways to deploy to GKE. I think there's a typo here. So so there's other ways to deploy to GCP. There's GKE, there's Cloud Run, there's App Engine, there's Compute Engine instances. In this case, we're choosing Cloud Run. What do we need? An Elixir Phoenix app, a Postgres database, a GitLab account, and a GCP account. So, because there's a lot to do, I just jump straight into the demo. or rather I can, okay, so that's worked. That's a good thing. Right, so maybe a walkthrough of what we need to do as far as the technical stuff is concerned. You need to create a GCP account. You need to create a GCP project. So if you're looking at the article right now, there's one of the first links I've posted there dictates how you do the process. And maybe I should open that. So this particular link, basically you open your GCP, right? Actually, I think it's easier to go through. Sorry about that. Yes, so this was causing my builds to fail. Basically, you should be able to come to this spot, create a new project. In our case, I had created Phoenix GCP, so you come and create a new project. You name it as you want to. And then once you're done, you can select the project from here, or you can come straight here, or rather here. And okay, so the project is still creating. Right. So when it's finished creating, you then come to this spot. The next item, of course, is to get permission to run your stuff on GCP. So for that, you create this IAM and admin. For that, you create a service account. Usually they're listed over here. So in this new project we've created, of course, we don't have a service account. So we'll then create a service account. Name it as you want. For this particular situation, since we're doing Gitlab CI, I'm just going to name it that. You should give a description, but in the interest of time, I'll skip that. And then there's 4 main roles, basically, that you're supposed to add. Okay, so that's the article. Sorry. I guess you try go slow. It's nice for blogging. So this particular. So once you have your service accounts, basically, you've seen how to navigate to the service account. So you click on create service account, you describe your account, and then these are the 4 permissions that you're supposed to add. Basically, project viewer, service account user, cloud run admin, and storage admin. We can do that right now. So project viewer, that basically allows the APIs that are controlling, so like the Gitlab CLI specifically, to be able to carry out these operations. The next item is the service account user, the cloud run admin, and the storage admin. So if you miss any of these, you're going to have a hard time deploying. And clearly we've missed some of them. Anyway, not to worry. Basically, these are the permissions that you're supposed to have, right? So once the permissions are there, you then come here and you create a key. Once you create a key, it's going to ask you to download the key. Save it to your downloads folder. Once you have it in your downloads folder, you can now go to the next step. I don't think I've missed anything. Yeah, basically that's it. So once that is saved to your folder, then you're good to go. The next item basically is to enable the GCP APIs. So basically what the APIs do is something like Cloud Run, you can define it as a resource on GCP. Basically, you're not supposed to be able to create new resources without enabling the APIs that control these resources. So for example, here we are going to use Cloud Run, Cloud Storage, Compute Engine, and the serverless VPC access, right? So if we miss the creation of any of this, then we end up in problems. Specifically, you get an error that says that you're not allowed to access that resource because you haven't enabled the APIs. I think I actually copied one of those errors here. So basically, it reads, token exchange failed for projects identified by this ID. Please enable Google Container Registry in Cloud Console at this URL. So it's pretty friendly. It even gives you the URL where you're supposed to enable this API. So once you click on that, it opens a page and you can click on enable and you're good to go. I should just close this. Sorry. So I won't go into these details because I've basically written it down in the article. There's more complicated stuff to do. Of course, you guys know how to create Elixir Phoenix projects, the mix.phx.new command. So I did that and basically came up with this project. So I'll try and walk through it from top to bottom. The new thing for most people here probably is infrastructure as code. So it has its advantages, and I think the strongest one for me is consistency and the ability to share your code with the rest of the team and basically have your infrastructure peer reviewed before you actually deploy it. So you can basically follow the same paradigms that you follow when you're writing normal code, except now you're dealing with infrastructure. So the first file usually you create, or the first number of items you create, is this main.tf file. Usually it contains a provider. So I'll urge you guys to go and read about Terraform. Some of this might be confusing, but I'm hoping at least the code is a bit self-explanatory, especially for those who've gone through the experience of creating infrastructure as code, or maybe infrastructure from the console perspective, from the GUI perspective. So you have to give permission to Google to run this stuff. You do a provider, and then in that provider, you give it a credential file path. That credential file path is basically the service account key that we downloaded. Typically, I store mine in a secrets folder. I want to show you guys this stuff, but it's a production thing. So okay, maybe I'll just change it after this. Basically, this is your whatever, is your service account, right? It contains the permissions that we declared. But here specifically, there's two service accounts. There's a service account that you're using to do the infrastructure as code deployment, and then there's a service account that you're using to do the Gitlab CI/CD process. This particular one that you're looking at is used to deploy the infrastructure. So it's what this provider uses to basically authenticate itself against the Google APIs. There's basically 4 modules here. The VPC that we are using. This gets a little bit more complicated, but basically you initialize your stuff on a file like this and you call them modules. We need a Postgres virtual machine. We need an Ansible virtual machine as well. The work of the VPC basically is to act as the network in which our resources reside. Specifically the Postgres VM, the Ansible VM, as well as the Cloud Run application, right? But then I don't know how many of you have used serverless services on GCP. In the past, you never used to be able to connect from a serverless resource to a resource in a private subnet, right? So about a year ago, GCP introduced something we call a VPC connector, a serverless VPC connector. So it allows you basically to to route traffic from a serverless VPC resource to like a VM that contains a database. This VM can be sitting inside of the private network and that's not accessible to the public. You can also create other resources like Redis or something like something like managed databases for Google. I'm forgetting what the name of that is. And basically have them inside your private subnet away from the public. So how to create that link? Actually, I have a picture here. There's a friend of mine called Peter who helped me do this image. Right, so I didn't get time to add it to the slide. So basically what we have here, what I was describing is, you have the public internet here, right? And then you have Cloud Run, our resource, right? The one that we're creating via the CI/CD process. And then you have these two instances. Ansible here is a bit of overkill, but I just wanted to demo the creation of, or rather, there's two things as far as infrastructure goes. There's creating an item and then there's provisioning it. So when you create a VM, you just deploy it, right? You don't say that you want Postgres inside it. You don't say that you want OpenSSL inside it. You just create it. But then there's the other part of configuring that thing, that VM that we call provisioning. So basically the work of Ansible here is to act as infrastructure as code that helps us to provision Postgres, I mean, not Postgres, but VM instances. The connection happens through SSH. And then on this other side of things, we have GCP, we have GitLab CI/CD. So basically the code is stored there. We also have items we call GitLab runners that basically run CI/CD. If you've used something like Travis CI or Circle CI, then a GitLab runner is basically their substitute, right? And of course, this is my local machine, and this is interaction via virtual, what do we call it? Code control, I'm forgetting the name. Code versioning, right? So I can basically SSH from my machine to Ansible and tell it to run instructions we call playbooks. In this particular case, we have a playbook called Postgres. I think I can just show it to you. Again, this stuff is probably too much, so I tried to write it down so that you guys can be able to refer later, and of course, for my own future reference, calling it being nice to my future self, right? So once your VM has been created, then you have Postgres. Once your VM has been created, then you can SSH to it via, of course, the usual SSH software. Basically, Ansible is the one that SSHs to this machine and runs what we call a playbook. So this is a playbook. It's in YAML format, and there's different kinds of YAML items. For example, GitLab CI is a YAML file. We'll run through that. This inventory file is also a YAML file. So basically, there's a bunch of YAML files for different kinds of platforms, and this one specifically is a playbook to create Postgres using Ansible, right? So the first step is you provision the Postgres instance, or rather, this is the name of the whole application. So an analogy I like to give for Terraform and Ansible is like when you go to a shop and you buy a laptop versus when you have the laptop in your house and you configure it to have your development environment. So in the initial part of that process, then you're creating your infrastructure. In the latter part of that process, you're provisioning it. What Ansible does is help you provision. So when you combine Terraform and Ansible, you have what, in my opinion, is a very formidable combination. The first item is, of course, to update cache. If you've done Unix commands, this is going to look very familiar to you, specifically Ubuntu guys. With a new apt whatever. What do you call it? Repository. Yeah. So you update cache. This is sudo apt update, and then you ensure that these items are installed. This is a loop basically. So it runs through all these items and runs the command that installs the latest version of that library, or rather that package. Excuse me. The next item is adding an apt key. So it's all basically Unix commands, specifically Ubuntu. There's nothing too new here. Once you get used to the syntax, it should be fairly easy. You create your variables. Oh, I think I misnamed this. The problem with copy pasting. This is a debug line that I was trying to find out what was wrong with my code. So basically, you can be able to print out some of the stuff that's going on in your project, and then you add a Postgres repository from apt. You install Postgres. So this is basically sudo apt install Postgres. Basically, you run this command, right? You're installing these items. Postgres SQL, you declare the version. These are a few more items that Postgres needs to run. Python 3 is used to configure, is used by Ansible basically to configure, what do you call it? To configure users and the database itself. This is part of that dependency tree for database configuration. You make sure here that the service is running. So on Ansible, you can have checks, right? You can have stuff that basically tells you don't move on to the next step unless this particular step is fulfilled. And then you can ensure the database is created. So it's another check. If it's not created, it creates it. Once you're done, you connect to the API. You connect to, oh, so I've copied this code from a different sample. You can substitute this with the name of the project, which is Phoenix Cloud Run. It won't affect anything because this is more of a label, and all my stuff here is basically parameterized. So again, that's an advantage of parameterization because it means that even when you copy paste code, you're a bit safe. So you set the user's password with no expiry date. You come and then copy these items from your environment and you run them, or rather Ansible does it for you. And then you ensure that the user does not have unnecessary privileges. You allow port 5432 on the firewall. You allow port 22. So funny thing that actually tripped me up when I was first doing this is you'll notice that here in, let me just locate that. You'll notice that here in the VPC network, in the VPC file, there's basically a firewall rule that allows port 22 traffic, right? So traffic from the outside coming into the VPC is allowed, but then there's also another layer, whereby the machine itself can block traffic, right? So if you don't come here expressly and redeclare port 22 to be open on the machine, then you'll have one of the firewall rules on the Terraform side working on the network side, but then the interface that connects directly, or rather the interface that is on your machine, is unable to allow port 22 traffic. So it's necessary to have both, or you won't be able to run, for example, your Ansible playbooks, which operate on port 22 via SSH. Of course, you can reconfigure that, but yeah, make sure you add the ports that you reconfigure over here. The next item is basically granting user privileges, right? Oh, so this is the Postgres configuration, file. I don't remember exactly what happens here, if I'm being honest, but it's basically the initial setup for Postgres. It disables some stuff, enables some security stuff. I think one of the items I did was to make sure that only traffic from these subnets is allowed, right? So if you're trying to access this VM, if for example we paste it in deployed it in a public subnet, and we don't want people to be able to access it, and we've made that mistake. Basically, you'd be able to block traffic at the application, at the OS layer. If you understand what I mean. So some of that configuration is done in this file. Once you do that, you then grant privileges, and I think these two are basically the same command. And then once that happens, you configure DBs to listen on this IP address. Actually, what I was explaining happens on this step, and then you restart your databases. So now your database will restart configured and accessible on the necessary CEDA blocks, right? So we call this CEDA blocks. I realize there's a lot of glossary terms here, so feel free to ask questions afterwards. Another item of interest here is the Ansible configuration. Maybe I'll just locate the things that are of interest to us, specifically this GCP compute plugin that is enabled. You need it to be able to basically run your inventory. So basically, when you're running Ansible stuff, you need something called an inventory. It's a list of the addresses of the machines that you want provisioned, right? On GCP, how you get that list of addresses is by running this YAML file via Ansible. It gives you a list of all the machines that adhere to certain tags. So you can come and specify tags here and say maybe all development machines should be listed. So that list is then passed to Ansible playbook, and basically that command runs to configure the stuff. All that happens here. In case anyone has a question, please just, I don't know if I'm missing any questions, just type it in the chat and I will get to it. And then here, basically, your virtual machine is created, the Ansible virtual machine. You then provision your files, or rather provisioning files is uploading the files that you need, that Ansible needs to run the playbooks, right? So like SSH files, the private key of the Postgres machine, its own public keys. Here, basically, we're uploading the private key, and then here we upload the second service account key, which basically is used to provision infrastructure. Typically here, I use what I call a sudo account, but it's not good practice. So when you're deploying such projects, basically just go and check. For example, if you're creating a GCP resource, just go and make sure that you accommodate the exact permissions that are required to create those resources, because if your stuff is compromised, then whoever gets access to that service account can do whatever they want on that system. Whereby if you specify specific permissions, then they'll have a very small footprint or a very small surface of attack. So let me just drink some water. Once that is done, you want to then upload these artifacts that I was describing, the configuration file for Ansible, the inventory file that lists the IP addresses via GCP, and then the actual playbook. So this playbook is usually independent of a platform. If you get an AWS inventory, for example, you'd be able to run your playbook against the AWS machine, as long as it's, for example, an Ubuntu machine, or it's a Fedora machine, or any other Linux platform, as long as you're able to customize these commands to fit. So for example, I think on Fedora, you'd be using YAM. I'm not sure, I haven't used it that much, but I think you get the picture. And then once that is done, you then go to remote execution. This, arguably, you could replace this bunch of commands with Ansible, but then there's a Swahili proverb that says kinyozi hajinoi. Basically, for those who don't speak Swahili, if you're a barber, you're not able to shave yourself. A different barber has to come and shave you. So basically, the Ansible machine can't configure itself. Terraform has to first configure it, and then it's then able to run playbooks against other virtual machines that are in the picture. So here's basically all the software that Ansible needs to run, right? So maybe the first thing to do, and this is common, especially for SSHing, you need to make sure that the private key that you're using to access the other machine is restricted to use only by that machine that is running it. So if for example, I have SSH keys on my machine, I should have 400 permissions done there. So only my machine is able to run this particular, how do I say, is able to use this particular private key, right? And then of course you update your machine, you install Postgres. So we're going to use this to test whether or not our Postgres, our Postgres database has been created. And then there's Python 3 pip here. It's one of the dependencies. I'm not sure exactly what it does. And then you, of course, add the universe apt repository, you update again, and then you also install Python 2. So I remember at some point I had just Python 3, and then I tried to run a few things. I got some errors. I ended up just putting Python 2. It's one of those situations where you're like, my code works. I don't know why. And then you do this get pip, and then of course you run Python 2 against get pip. When you're done, you remove it, and then once that is over, you then install Google Auth. This is used along with Ansible to help you to basically authenticate your stuff before running it against the Google API. So I think by now you've noticed there's various ways to get at the Google API. There's Ansible, which uses the API. There's Terraform, which uses the API. There's Gitlab CI, which we're going to get to, that also uses the API. And basically to access all those API resources, you have to enable the APIs. We spoke about that briefly. It's also covered in the article. You then come and add the Ansible repository, apt repository. You install this software properties package. You then move the Ansible CFG into this location. This is the default location, basically, where Ansible locates its configurations. So if it's missing there, you have to specify a custom one, or rather you put it in the right spot. So I personally chose to just move it into the right spot. And because it's infrastructure as code, it's repeatable. I don't have to worry about being able to run the same commands later, because I'm pretty forgetful. Once that is done, you create this folder, the install folder. You echo, basically I'm using this to create a command. So if you notice over here, there's a greater than sign. So on Unix, when you echo content, you can print it, quote unquote, into a file. And in our case, basically, I basically substitute like the instance IP, the public IP address of the Postgres instance, to this environment variable. I do the same for this SSH user. I do it for this Postgres DB name, and basically everything that is over here. There's a way in which you initialize these environment variables. Maybe if there's time later, we can go through Terraform as a topic on its own, and Ansible, of course, that's integration. And then it basically creates a command and puts it in mtech. Postgres SQLDB.sh. So at the end of it all, if I have several scripts, I will come and echo them into this file, or maybe I'll create several files using the same echo pattern. And then I then change the mode of these files that have been created in the install directory and make them executable. So that's what this +X does. And then once that is over, you then execute your playbook, right? So I'll just do that now and hope everything works. So again, or rather, let me just go through this one more time. This IAC folder typically is created in an external repository. I've put it here to make it easier for us to be able to access this code. But when you're doing your own stuff, it's good practice to create it as its own repository, because basically you won't be creating infrastructure for just one application. You'll be creating infrastructure for maybe the database, you'll be creating for the API, you'll be creating for the front end, and you can basically describe all that stuff here, right? So to be able to run this stuff, I have this secrets item here, which is used by this service account is used by the inventory and the playbooks to basically collect IP addresses and run Ansible against that. Also, it's used by Terraform itself to create infrastructure. So at the moment, I am in the IAC folder. So I've gone back to the previous history. So this is where my stuff is located. And then I basically CD into, or rather the first step is, if you notice over here, there's just a second. Over here, there's an environment file. So this basically mimics the items that you would add to your CI/CD settings page. We'll get to that point. To run this, I'll do source end.sh. So this is basically configuring my terminal to have these environment variables. Basically what the CI/CD settings page on the GitLab CI would be doing for you. But of course, I want to mimic the same environment on my local installation. So once that is done, if I come and echo, say, log level, then I'll get debug, right? But if I open a new terminal, okay. If I open a new terminal and then I echo the same, it's empty, right? So you have to set your environment variables or you're going to experience an error. The next item is then Terraform. Typically, it's Terraform init, which is going to look into, hello?
Sorry to interrupt. Just reminding you, 9 minutes remaining.
Oh, okay. I don't know if we'll be able to complete this stuff in the 9 minutes. But if folks are willing, we can have an extended call, or we can do it some other time, whichever works. But let me just proceed until where time will allow. Of course, you can refer to the written guide. So the next item is you initialize your modules. In this case, we have this modules declared. If you come to this main.tf file, there is a VPC module, there is a provider for Google, there is a Postgres machine, there is an Ansible machine. So basically what we want to do is initialize all these modules. Right, I'm in the wrong place. pwd, so cd IAC, and then Terraform init. It runs through the various items. These are the providers that are being installed, and then my modules are already declared, or rather already initialized. And then once that is done, then we run Terraform, apply, auto, approve. You can skip this auto approve, and then you'll get a prompt that basically asks you if you want to, what do we call it? If you want to say yes or no, basically the normal prompts that you usually get when you're installing software. But basically now this infrastructure that we described over here is what we have written in terms of code, and it's all going to be created now by the infrastructure. Typically, you would have to come and create this on its own, create this on its own, create this on its own. You get the flow, right? But when you write stuff as infrastructure as code, then you can run all that in one command. So typically, depending on the size of the infrastructure that you've declared, it might take some time to deploy, but let's see how quickly this goes. So while that's happening, I think I can take questions before we get to the CI/CD part, because this is going to take a while. It's a build. Fedora uses DNF. Who uses YAM?
They moved from YAM to, they're now deprecating YAM for DNF.
Okay. So this is basically creating the VPC, the network, the virtual private cloud in which our infrastructure is going to be based. Once it's done, of course, it goes according to this. I think it's sequential. I'm not so sure, but I think it goes according to all this. If you go to this VPC network folder, you'll find other files where we've described this infrastructure further. So if you notice, you can basically have two modules using the same source, right? So you can have a VM that is standard. So you can have like the dev VM, you can have the staging VM, and you can have the production VM. And all you need to do is create different modules here, but then have the same underlying code. So it allows reusability. So while that's happening, so it's gotten to this section. Just a second. This one to go away. So it's gotten to this section. It's basically running this stuff. And then when it's done, it's going to run this, which kicks off the Ansible provisioning. Once that is done, I will pick an IP address from the results that I'll get, and then go configure it in the GitLab CI/CD settings, and then run CI/CD. I haven't made the process complex. Usually you'd have, so if you go to this file, it describes the CI/CD process in GitLab language. I've disabled tests because I didn't have time to actually get this to work, but when I push the code, you should be able to just activate this, and it should be self-explanatory. But if you have questions, feel free to DM me on Twitter or WhatsApp. Once basically you declare this, so you're declaring this stuff, this environment variables in your CI/CD settings, and then you then hit the build stage, which comes and runs these commands. These are the services that you want preloaded on the container that is running, or rather this runner, the container that is running your build stage. And then you have the service account, which we spoke about earlier, the initial service account, not the infrastructure one. This one is used for CI/CD, basically. You use it to build the images and deploy the containers into Cloud Run. So it's basically a build stage and a deployment stage. So I think you're all familiar with Docker build commands. Once that is done, you then run the Docker push command. You'll notice here that we are tagging the image name by the CI commit short SHA. So this is the hash for your commits. If you've ever looked at your GitHub or your GitLab, where your commits are listed, there's a short hash, right? So we tag our images with that hash, and then we push the tagged image. So this is still making progress, and it's complete. So even our final, what do we call it? a final command runs successfully. If you haven't been able to follow well, don't worry. I will complete this article and share it, and of course make things clear. But I would also appreciate your feedback in terms of making it a bit clearer. And yeah, I think you get the idea. So here then you have your private IP for the Postgres machine, right? So you then pick this IP address and you come to, so this is the last failure that I got just before this call started. I think I've shown you guys. If I click on this, it's going to take me to open link in new tab. It's going to take me to the page where I can enable that API. So while that's loading, let's go to our CI/CD. You've seen where I've clicked on settings, and then you come to variables, you expand this. I pre-added this environment variable so that we can at least have a shorter demonstration. But if I open, say, one of these, I've declared the app name for this application, right? There's another similar name here, the Cloud Run Service. Typically, you would have, say, instead of all being here, instead of all environments having the same variable, you can come here and say development. You want to have the development environment, and then you create the wildcard development, and you basically have your environment variables restricted to an environment. But in this case, we're not doing that, so we can skip that. We're not updating it because it's already pre-configured. But the item that we're interested in is this database host. So you'll notice that it didn't actually change from the previous command. So just when I was starting this call, I destroyed the infrastructure. So this is the command that I had run. Let me just show you guys. You can again destroy all your infrastructure using one command. Terraform destroy, auto approve. So just before the call, I ran this command, and then a few minutes ago, we then ran Terraform apply together. So they're basically opposites, right? And you can specify a specific resource that you want interfered with, quote unquote. So once that is done, you update your variable. We're not adding anything, but another item of interest here, I think, would be this VPC connector name. Let me just show you where that is useful. If we go back to GitLab CI, we were talking about this script. Maybe while I explain that, let me trigger the CI/CD process. So we see if we get time to see it finish up. I hope it doesn't fail, but I hadn't finished debugging it. Right, so these are some of the items you're supposed to ignore. So what we can do to trigger a build is cd, go back to the previous folder, do a git status. It shows that this terraform.tf state needs to be ignored. So code.gitignore opens the gitignore file for me. I then add, no, okay. So remember that our stuff is in the IAC folder, right? So to ignore it, I'll do that instead. I hope that makes sense. So let me trigger a build by pushing. So git commit -m, which is updates.gitignore with this file. So you have two options basically when you're committing. You can add the file manually, or you can come and add a -a flag there, which basically commits all files that were previously staged. So it won't interfere with new files, and it won't interfere with files that are maybe added but not in the previous commit, right? So if I do that, it commits, and then if I do it, mind you, I was on the CI/CD branch. Not that it matters at the moment because I don't have any deviation of commands based off of the environment, but at this point we can push and basically trigger a build. So if we go back here, just a second. If you go to the pipelines page, you'll find that, so this happens a lot basically. My message to you is don't get discouraged by the the red stuff. It happens a lot before your code actually works. And this time I'm not even sure if the second stage is going to run, but I'm almost positive the first stage is going to run because I debugged quite a few things, including enabling this API page, right? So you have to be, of course, in the correct project. In our case, we're using the MTech project because I ran out of projects in which I can add billing accounts. And if you don't have a billing account activated, then you don't have access to stuff like the storage APIs. You also don't have access to stuff like Cloud Run, basically anything that is not offered on the free tier by Google. You'll have to add stuff to be able to use. So as you can see here, this API is enabled. But typically, your APIs are declared, your APIs, or rather your resource APIs, are found over here. You can just come to this main search bar and type APIs, and it's going to list for you all the APIs that are enabled. And then you can come to this library and choose the APIs that you want to enable and make sure that everything that your application needs to run is available as an enabled API, of course with billing on your GCP account. I also wrote, I guess, extensively about this when I woke up very early in the morning. So that part should be a bit clear. If it's not clear from this talk, you can refer to the article. And then, yeah, so basically you can come and click on this and watch our build happening. I think most of you are familiar with this. So this is specific to Elixir, but of course you can adopt the same process for your other applications. At Kala, we have some stuff on different languages. We have Go, we have Elixir, we have PHP. There's also, I think, a Spring API. On some personal projects, I'm basically using Elixir alone. So I think all of you are familiar with this process, and basically it's not restricted to Elixir. If you come from a different background, you can adapt the same process. As long as you can build a Docker file and provide environment variables, you can adapt the same process to fit your way of working, right? So we were supposed to talk about this VPC connector. I don't know how much time we have. We're 6 minutes past. So maybe just the last item before questions, if people have any. If you come to this VPC network, there's this item called the serverless connector, right? So what it does is basically create a bridge from this is what we're creating there, right? It basically creates a bridge from Cloud Run to the Postgres instance. Previously, that was not available, but now using this Google beta provider, you'll also notice that we're using a different provider than all the other parts of this application because the VPC connector API is still in beta. So you have to declare a separate provider for this particular item. Yeah, and then, yeah, I think unless someone has a question on this, we can stay at this build and hope that it works. Yeah, so please, if you have questions, now is the time. We'll probably have to do some debugging.
Yeah, question.
Yeah.
Environment variables or a secret file? Which one would you go for?
There's more secure ways to do this. So like Terraform, there is Vault. On AWS, there's various options. As far as the secret file goes, like the prod.secret.exs, I don't know if that's what you're referring to. I think I just rather pass what I need via the environment variables and have it happen at the build stage or at the runtime stage.
Yeah, and
But there's
sometimes,
cleaner ways to do this and more secure ways to do this. This is not like bulletproof.
yeah, because sometimes you run
Sorry, I'm losing
building
you.
a Docker image, and I'm saying sometimes you run into the problem of having a public Docker image,
Yeah.
and this image will
Oh,
contain,
sorry.
if you put in environment variables, anyone can inspect that.
Yeah, yeah.
Yeah. So yeah, I understand. So
So I mean, as our friend here is saying, do not do this in production. This is a demo. There's safer ways to do this. Like if you're doing stuff on Kubernetes, there is the whole idea of secrets. If you're using Terraform, there is HashiCorp Vault, so you can use that to share secrets. There's cleaner ways to do this, right? That's the main thing to acknowledge here. So while that is running, let's see. So at least we've had one success. Let's see if this deploys successfully or if we'll have to do some debugging. I haven't interfered with this at all. Any other questions? Is there a question I haven't seen here? See, good. The reds, they usually like you're doing out of like 100 builds, your reds are probably like 80. So if you get bored, you don't make any progress.
I have a question.
Uh-huh.
I have already posted it on the Slido.
Oh, okay. So John Sandish,
See,
on the slide, so Chantel has access to the slide. Chantel,
oh,
are you
okay.
there?
I mean, I think you can just paste the same
sure.
question here.
Actually, I am completely new to this CI, CD, and GitHub pipelines or GitLab pipelines.
Yeah.
And what will be the uh, uh, I, I'm asking you what is the right way to start
Uh-huh.
learning this CLTD and all those things. I'm asking you a path. If you can help me, suggest a path like which blog story, after that
Uh-huh.
which videos to watch.
Okay.
If it takes time, you can post answer on WhatsApp group also. I'm okay with
Yeah.
that. But I need a complete path that
Uh-huh.
will help me learn and understand.
Okay. So I will finish up the article I was writing and of course share it to the group, or you can always refer to the link and then I will update. I will also put links to like learning um, websites. Though I think one of the main things I would recommend is a website called learn.hashicorp.com. If you're interested in Terraform, they have their own tutorials for all these products that they offer. Specifically, you're interested in Terraform, and they take you through starting out on, say, the AWS route. In our case, we're doing Google Cloud.
So should I learn Terraform first or Ansible first?
The simplest thing is to start with GitLab CI, right? Once you understand what this file does, where is this file?
Okay, Sigo has
Wha-
posted something.
Yeah. So once you understand what this file does, it basically creates instructions for everything, right? At this point, we haven't even deployed our infrastructure. We haven't created our infrastructure. And the only time we're going to interface with what has been created by Terraform is at this stage, whereby we are declaring the VPC connector, which we got from here, right? So you see this VPC connector. We then use it here, right? So once you understand what happens in this file, then it's easy to then adapts the same way of thinking to Ansible and also to Terraform, right? So Ansible uses YAML to configure stuff, and then Terraform uses the HashiCorp language. It's a proprietary language that they have on their own, that they've open sourced. It's built in Go, which is basically this stuff that I'm showing you, those TF files. Yeah, so the order would be, maybe another resource that I can help you with is
You can take some
GitLab.
time and blog about it. I think it will take much long time to explain. There might be other questions.
Yeah, sure. So this particular file, maybe in closing, this particular file will teach you exactly what GitLab CI does. It's not like a good guide for a beginner per se, but if you're not against reading documentation, then this is going to explain everything that I do on this file. And then I noticed there's someone here asking about where to get the code, John. So I'll push the code. It's already on a public repository. In fact, I think I can just share it to the group. So this is still happening, and it failed. Why did it fail? Because we have not enabled the Cloud Run API. So what we do is copy that, open a new tab, paste it. I think I've managed to show like a bunch of all the various concepts. It loads the API page, and then you can then enable the Cloud Run API, right? So everything that I had not declared when I was starting out or enabled for this particular project, I have to enable. So maybe a small background is this particular project I used to run this blog, and of course it just needs a virtual machine and a MySQL instance if you've done Ghost. So I hadn't enabled Cloud Run or any of those things. The reason I didn't use the Phoenix GCP project that we had started with is because I ran out of billable projects. So when you're still on the free tier, there's a limit to how many billable projects that you can add that won't be charged any money. So once we've enabled that, where is it? Okay, so yeah, so okay, it's enabled. So now we can retry and hope that our stuff gets deployed. And then let me see if there's another question. I'll share the code basically. Don't worry about that. And I think this link is publicly accessible. But of course, I will have to come and delete the environment variables because they are personal and you can create the same project. I'll list them in a file, so it's easy for you to reconfigure them yourself. Some you have to get from running Terraform and Ansible. So you need to run your Terraform and Ansible stuff first before you come in and do GitLab CI, which is kind of contrary to the way in which I recommend you learn this stuff. Also, I think you can just focus on Ansible, for example, and just understand what it does, focus on Terraform, because they're a bit different, and it's basically combining disciplines. Let me see if I can open this in a private window. Yeah, so this is publicly accessible. Let me see if, yeah, so you can't access the settings. I don't think I have to delete my stuff, but then I'll have to disable it because if someone comes and runs extra builds, then it counts against my GCP and my GitLab. So at the moment you're restricted to, I think, 400 minutes of CI/CD time on GitLab, but this should be accessible to you guys. I'll update it on the article, but let me share this right here. Yeah, John, I totally understand. I like to teach, so, and especially pair programming. I think I do better on pair programming sessions than I do on such sessions. So, I mean, when there's time, we can have a conversation, and maybe I can take you through a few concepts. But yeah, any more questions?
Thank you, Collins. It's been an enlightening session. So I want to thank everyone for being here, the audience, the organizers, and most especially the speaker. Thank you for attending today's session. Our next webinar will be on 30th October. More information concerning the webinar shall be communicated later. But if you have any questions for future webinars or you would like to be the host, feel free to get in touch at ElixirKenya on Twitter. Also, Collins has shared some good insights and his article, I'm pretty sure we'll be able to share it when it's complete, and other articles we will add inside it. Thank you, everyone. I think Sibu kindly end the session for us.
Okay, that was abrupt, but I guess sorry about that, Collins, but
No
we've
worries,
just
no
run out.
worries.
Yeah, we've just run out of time, so we just had to do this.
Yeah.
We'll end the session right now, so we can now continue behind the scenes. If
Yeah, sure.
yeah,
If you
you're
need an
free
explanation on why this has failed, I know the answer, so feel free to just DM me. It's
around.
pretty simple. Yeah.
All right, no problem. So thank you so much, everyone. Hope to see you on the next webinar. It was nice having you. Bye-bye, everyone.
Thank you for having me. Bye.
Thank you so much, Collins. Mush.
Okay.
Oh, and
Nice